Alright broski, it's T and I'm back, man, with a new video. This just popped up on the radar. I thought I would take a look at it, review it with you. It's called Menno, Henselmans. Can the body only absorb 20 grams protein per meal? Science. Muscle, full effect. Okay, let's see what he has to say. I'm always curious what these so-called professionals have to say, or gurus, or whatever.
Is it true that the body can only absorb 20 grams of protein per meal? And if so, what are the implications of this for your daily meal frequency?
Does that mean a sedentary person can, only a sedentary person, or I guess we'll see what he says. Hold on.
How many meals you should eat for maximum muscle growth? This is a topic that is riddled with truth, myths, and accordingly, a lot of confusion.
It is, because here's the problem with that. We know that protein is being broken down and it's building up all the time. So as you're making your way through the day, it's constantly breaking down and building up at the same time. So can it just absorb 20 grams of protein? No, it can absorb a lot more, because you can shut off the catabolic hormone and start a growth phase. Yeah, you can start building muscle, literally sitting there eating protein.
So in this video, I hope to...
If a fat person can overeat and get fat, a cell can blow up getting fat. These cells blow up like so big in fat cells, accumulating fat. Well, then your muscle cells should be able to blow up too with protein in it, if it exceeds that breakdown. See what I mean? Now you're exceeding it with what? Carbohydrates, so you're getting what? Fat cells. Well, what about muscle cells? Don't they get bigger too?
Clear up that confusion and present you a clear idea of what your body does with protein and what that means for how many...
Why is he showing tofu and shit, some fake shit? That isn't meant for your body. Now that's real protein, the eggs, but look at him. He's frying it in a pan. This is unnatural. Nobody in nature would fry their eggs, they'd eat it raw. No animal out there fries anything or cooks anything. They eat everything raw. That's how they're able to be big and strong and healthy.
Meals per day you should eat. To start with, none of this has anything to do with digestion or absorption. If we take the idea at face value that the body can only absorb 20 grams of protein per meal, it is decidedly false. It is very clear that the body can...
I agree, of course, because it's constantly in a flux of breaking down and building up.
Easily absorb more than 20 grams of protein per meal. What people mean is they're talking about protein synthesis. So let's get our terms straight here. When protein goes into your body, it first has to be digested. Digestion basically means it's broken down into pieces that the body can absorb into the body. So absorption requires the nutrients that you consumed going into the body and generally being available in the bloodstream. After absorption, the body can metabolize these nutrients. So you want your body to not just digest and absorb the nutrients, but also metabolize the protein, and that means that the body can use it for example, muscle protein synthesis in your muscle.
Okay.
Muscles, which makes them bigger and therefore makes you more muscular and stronger. So it's definitely not the case that there's any limit on digestibility or absorbability of protein. You would have to consume absolutely ludicrous amounts before that will ever become an issue. The body's energy harvest is...
Yeah, that's what I've been trying to tell people. Protein synthesis needs to exceed that breakdown to get that growth. Yeah, definitely. Yeah.
Exceedingly efficient, and the body has no problems getting all the protein as well as all the calories from the food that you eat. So absorption is really not an issue. What is an issue is muscle protein synthesis. Yeah. And here, there is a lot of truth behind this idea that after 20 grams of protein, at least high quality protein, such as whey protein or dairy protein in general, there is very little additive effect anymore of going higher up in protein. As you can see in the graph here, after 20 grams of protein per meal, there is essentially no further stimulation of muscle protein synthesis, especially not at rest. Why is this? It's because of...
Not at rest, but okay, I agree with him. Yeah, okay, at rest, you're sedentary, whatever. What about if you injure muscle fibers? You're going through a phase where you want to build some new fibers through cells, accumulating in cells. So protein synthesis is extended for that entire week, and so are blood levels, while you repair and remodel new nascent muscle fibers. Isn't that how it works, Mr. Menno?
What researchers call the muscle full effect.
You didn't talk about that part. You didn't talk about when muscles are injured, Okay, they go through an injury phase, or you want to call it damage, this damage, injury, damage, not this regular blunted damage that people do chronically in the gym, damaging their muscles chronically, not getting a micro tear. They're just damaging muscle fibers or proteins. They're damaging proteins. Let's just put it that way. They're damaging proteins in the gym. They're not causing micro damages. They're causing protein damages in the fibers. Okay, so we know that muscle injuries, or micro injuries in the muscle fiber, protein synthesis is extended for that entire week, and so are blood levels. So there you go. You are actually building muscle as you sit there for that entire week until that muscle is repaired and remodeled. But it could be catabolic if you don't eat it right, if you don't feed it right away. And there is a phase you have to feed it right then and there, the most protein that you can, right after that damaging phase, that injury phase.
Fact. As you can see in the graph here, if you just keep pumping in amino acids into the blood, then at some point your body's not going to respond to that anymore. The body will be refractory to it. And
no, well, not when it's injured. And I can prove that. See, in this report here, if you bring it out, it's called alterations in protein metabolism due to stress of injury and infection. Well, if you scroll down here, it tells you negative protein balance cause. Hold on, let me bring it up here to the beginning. The negative protein balance caused by severe injury results from a large increase in the rate of protein breakdown. Yeah. Although synthesis is also increased, the increase is insufficient to offset the increased rate of breakdown. See what I mean? Although synthesis is also increased, the increase is insufficient to offset the increased rate of breakdown. See what I mean? The increase in muscle protein breakdown is coupled with an increase in the outward transport of amino acids, which is consistent with the role of muscle and provide amino acid precursors for synthesis elsewhere in the body. The negative amino acid balance persists across the muscle even for the person in the fed state. Furthermore, increasing the amount of protein intake has no effect on the rate of muscle protein synthesis. The alteration, transport, well, they go on to talk about a whole bunch of stuff. I can't go through the whole thing here, man. It's complicated. Here's another part. You can read this. The net synthesis of catabolism of muscle protein depends on the balance between the rate of protein synthesis and breakdown. That is the rate. So if you eat more protein, you suppress this catabolism. The precursors for protein synthesis are derived from either protein breakdown or from transmembrane transport from the plasma. The amino acids resulting from the protein breakdown can either be reincorporated into protein or released into the plasma. Exogenous amino acids given in nutrition can only be incorporated into protein after being transported into muscle cells from the blood. Thus, the process of protein synthesis breakdown and transmembrane amino acid transport is linked and is necessary to evaluate the response to stress by quantifying these three related processes. Consequently, results will be presented by techniques. So for infusion, trace amounts, in the blood, something, whatever. I'm not going to go through the whole thing, man. This is complicated, bro. It's quite lengthy, okay? So they talk about a bunch of things there. If you want, you can read it yourself. It's in my community section. But I can also prove this part. So this is satellite cell in aging. Let's say a satellite cell is in aging. Use it or lose it, whatever. So there's a section here will tell you that in response to injury, satellite cells are able to activate and re-enter the cell cycle, creating new cells to repair and create nascent muscle fibers while preserving a small population that can return to quiescent for future regenerative demands. Okay, in response to injury, what are they talking about? Exercise. They're talking about this injury is micro injuries. And so to get those micro injuries, that's a specific kind of training that you're doing. You understand me? That training is based on periodic lifting. It isn't based on chronic lifting. And it's based on you have to eat a shitload of protein, like I read in that last report, because you'll get an apoptosis. So you have to eat a lot right after that workout. A ton of protein. You understand me? To store up on it in the cell. That's your whole basis. And then you carry on the rest of the week. Because of this type of injury, like it read in there, an injury, protein synthesis is extended and blood levels are elevated for that entire week till the repair and remodeling is done. And I can bring up more reports, but it's tiring to keep bringing up stuff, looking around for them. I'm tired. I used to have them on my old channel. I don't anymore. But anyways, let's go on with this. This is more important.
To it. And the mechanism there is essentially that you cannot eat your way to the Mr. Olympia. So the body will only stimulate a certain amount of muscle protein synthesis that it needs, because muscle protein synthesis is a very energy intensive process.
You can't eat your way to the Mr. Olympia, but you can injure your way to it. You can micro injure your way, and that protein synthesis is extended because you've got an injury now in your muscle fibers. You've got the cracks and the domes to fill up in there, and getting nascent muscle fibers, like it said, it gives you nascent muscle fibers. Look, boy, this guy is really out to lunch. I think he needs to study a lot more of these things because he doesn't understand. This is satellite cells. Satellite cells build muscles, okay? And they're nuclei donated there to further that domain growth, blah, blah, blah. In response to injury, satellite cells are able to activate and re-enter the cell cycle, creating new cells to repair and create nascent muscle fibers while preserving small population in return for quiescent for future regenerative demands. You understand me? That kind of training is very specific, and you can make your way to the Olympia doing that, actually. But you probably wouldn't look as good at them because they take anabolics to give this polished look. All right? Now, let's go back to him. You have to know the different modalities in training. What are you shooting for?
Needs, because muscle protein synthesis is a very energy intensive process. The body doesn't just want to go around and building a lot of muscle just because one time you killed it.
No, it doesn't, but it will be forced to build it because it thinks it's dying at this point. Something happened traumatic to the body to cause those micro injuries all over the body. And now it has to go through a phase of repair and remodeling, and it thinks, wow, this was so traumatic that will actually grow new nascent muscle fibers. It won't just repair muscle, but it'll give you nascent muscle fibers. You understand me? And a donation of those nuclei so it can further that myonuclear domain size limit, where it reaches a ceiling limit during hypertrophic process.
Here, and you ate always protein, and subsequently the body makes you Ronnie Coleman. Yeah, buddy!
Just eating protein doesn't make you Ronnie Coleman, but you could be like Ronnie Coleman if you consistently lift periodically and cause these injuries to the muscle fibers so that the satellite cell can wake up and then repair, create, remodel, and give nascent muscle fibers, and boom, future regenerative purposes, it'll set aside, and then boom, you carry on. Get it? That whole week, you got to focus on growing those muscles now. That's the whole point. Yeah.
It doesn't work that way. In nature, of course.
In nature, that's how it works. In nature, dude, get it? I'm not talking about fake people with steroids building fake muscles like Ronnie Coleman, sarcoplasmic muscles.
The body has evolutionarily adapted to only building muscle when it's absolutely necessary, because otherwise it would waste a lot of calories.
Exactly. So you have to put it in that position, evolutionary, to grow, evolutionary, get it? By injuring the muscle fibers and not just chronically lifting there in hopes that you may get some mass on the myofibula, even though you won't, you're not, because you're eating a herbivore diet and you're creating sarcoplasmic muscles, which are based on glycogen loading, sucking it in there. Testosterone does not build muscle, but it will build a lot of fake sarcoplasmic muscle for sure, a sex hormone, get it?
Energy on that. If you don't need the muscle mass, that is not adaptive. So the body will only build muscle to the extent that you stimulate that muscle growth, usually with strength training. So you
No, not necessarily strength training. It could be injury training as well. Ha ha ha, I just told you, periodic lifting. It says there periodically. Look, shall we go back to how they explain this? They don't say chronically here, bro. Guess get broski. I'm just using one report. I can use millions of them. It says here, this review examines how periodic activation and cycling of satellite cells through exercise can mitigate. And then it says senescent acquisition, myogenic decline. That's for old people. But I'm just using this as reference. See, in response to injury, it says there, in response to injury, bro, satellite cell is able to activate, re-enter the cell cycle, creating new cells to repair, and create nascent muscle fibers while preserving the rest. Get it? New stuff. You're getting more. Get it? By injuring muscles. That is something different, something new and improved you don't even know about.
So you could say that in terms of muscle growth, being a glass and how much you fill up that glass. Strength training basically determines the size of the glass, and nutrition determines how much of that glass you are filling. In other words,
yeah, okay, you're talking about a limit. We know that. We know that muscle has a myonuclear domain size limit. You understand me? We know that, but we want to further that domain. We want to bypass it. How do we do that? By injuring the muscle fibers so that the satellite cell wakes up, enters the cell cycle, and donates its myonuclei because nuclei synthesize protein. We do know that. It's in science. It tells you that. I just proved it too. See what I mean?
researchers will say that nutrition is permissive for muscle growth, whereas strength training is the thing that really stimulates the muscle growth. This is a little bit of an oversimplification.
No, strength training does not stimulate the growth of muscles. Protein does. This is bullshit. There's an open window there, but it itself does not promote that.
But I think it drives the point home well for most people. So it is true that in most situations, after 20 grams of high quality protein, there is no additional further effect on muscle protein synthesis. However, there are a few...
Not if you're sitting there, but additional is working on people that have injured muscle fibers, these micro-injuries.
Two very important caveats. First, this refers mostly to research at rest or research in the post-exercise period where people train to have relatively low training volumes or only exercised a single body part. When we look at research in which people do a substantial training volume, especially of full body training, we see that the...
now he's getting to my realm. Full body training. Does response to myofibrillar protein synthesis to ingested whey protein during energy restriction in overweight menopausal women? Okay, I don't know about that one, but I do know the full body one that he just mentioned.
Full effect increases, so the ceiling of muscle growth increases up to about 40 grams of high quality protein. That's a pretty big difference.
Yeah, because you're using your entire body now. You're not just doing one body part.
Of course, it's about double. That means that after your workouts, you can utilize significantly more protein. Nevertheless, 40 grams of protein, or about 0.6 gram per kilogram body weight, is still not that much, and it's mostly the first meal after the workout in which
it is very little protein. If anything, if you're looking for growth, you're going to need a couple of hundred grams of protein.
Occurs. However, there is another potentiator of muscle protein synthesis and anabolic signaling, and that's fasting. After longer periods of fasting, we see that anabolic signaling can reach higher levels than before. This makes sense.
Yeah, starvation that may go to what they call the rebound effect. So you starve yourself and then you rebound by eating a lot of protein, and you try to increase some growth there. It's not going to go that much further.
In terms of the body having a greater demand for muscle protein synthesis when it didn't have a lot of muscle protein synthesis in a period before.
Only because you starved it, no kidding, right? It's going to rebound. That's what's going to happen, because now it thinks it's dying. So it's going to rebound by giving you, it's going to accumulate more of that protein on to the myofibrillar because it thinks it's dying. Again, your body is meant to keep you alive. So you're doing these tricks to kill it, to pretend it's like, oh, I'm killing you, you're dying, so you have to give me back something in exchange. And he'll be like, yeah, I gotta absorb more protein because when the next hit comes, I need to keep you alive, you motherfucker. You're killing me.
Whereas if you keep flooding it with amino acids, then you'll see that the body has the muscle full effect and it becomes refractory to further stimulation with amino acids. So again, makes perfect sense from an evolutionary point of view. If you were starving in the period before and you now get access to a lot of protein, then the body will use that protein.
Again, that's called the rebound effect. We know that in science. Yes, okay.
Protein to repair all the muscle and the lean body mass that was lost.
Repair the damaged proteins because you're chronically lifting, or is this micro-injury? So you didn't mention.
A higher level of protein that the body will use to restore and build new lean body mass, and therefore stimulate muscle protein synthesis. Caveat 3 is that this only refers to muscle protein synthesis. We also care about muscle protein breakdown. And there are a few studies that find that while you don't stimulate more muscle protein synthesis beyond 20 or 30 grams or 20 or 40 grams of protein, depending on whether you're at rest or after a serious training session, we see that muscle protein breakdown levels do increase past that point. Now, muscle protein breakdown levels, they don't change as
not during these muscle injuries. If you have achieved a level of micro injuries, you're not. It's going to be extended. It's extremely high at that point.
Much as as muscle protein synthesis levels. Muscle protein synthesis levels are the principal driver of changes in muscle mass and total protein turnover and net balance levels. Why? Because it's much more efficient for the body to stop synthesizing new proteins than to change muscle protein breakdown levels. Basically, the body doesn't go about breaking down protein for no reason. Muscle protein breakdown is usually there because either it's really necessary to catabolize muscle tissue, or it's part of muscle repair. You can think of this as like building a house. Building muscle is like building a house. When you want to add a balcony, for example, to your house, you can't just tack the balcony onto the house as is, right? You need to open the wall, create the door, maybe add some windows, maybe even break out the whole part if you want a nice open view, yada yada. So it's just like that with muscle growth. You can't just add a piece of muscle on top of it. You first need to remodel the tissue, and that involves some protein breakdown. So, long story short, muscle protein breakdown levels, they are not nearly as high as synthesis levels, and they don't change as much. So the practical utility of this isn't major, but there is research indicating that there will be a net further increase in muscle growth potential, even beyond 20 to 40 grams of protein per meal, because of a further reduction in muscle.
Yeah, I would agree about some of that, yes.
Protein breakdown, even when muscle protein synthesis is already pretty much maximized. Now, I would say that the research methods used to estimate the level of protein breakdown in these studies is a bit controversial. They have been questioned. So yeah, with that in mind, take it with a little bit of grain of salt. But I think it does explain why the 20-gram absorption limit doesn't really pan out in practice. Because if you would think about it, that would require at least 6 meals per day to maximize muscle growth. So theory aside, what do the actual data say? Well, we have a few studies on training frequency, and generally the trend is that we don't see these clear effects that you would expect based on the ceiling of muscle protein synthesis for muscle growth, for long-term muscle growth in studies. For example, one of the best and most interesting studies I think on this that we have is the Norwegian Meal Frequency Project, where they had a group of trained lifters do a training program with either 3 or 6 meals per day, all else generally equal. I would say that there was a little bit of problem with the calorie control, which we'll get to in a moment, but overall they found that the 3-meal group had better gains than the 6-meal group. They were roughly equal with a trend towards better gains in 3 meals. That was probably because the 3-meal group had a slightly higher energy intake, but if we compare the research on protein intake to that of energy intake, we see that the effects of energy intake on muscle growth are very small, whereas the effects on protein intake are much clearer. So overall, I would say that this is pretty strong evidence that there are probably not massive benefits to consuming more than 3 meals per day, especially if you time your protein well, where you have most of your protein in the post-workout periods when the muscle full effect is delayed and you can have higher levels of muscle protein synthesis. So I think that
that's kind of funny, man. Yeah, eating more, yeah, definitely. Okay.
Basically sums up the whole practical application of this video. You need at least 3 meals a day, most likely because of the strong limit to how much muscle protein synthesis your body will allow.
Okay, this is ridiculous. So you're going to spend 100 years trying to build muscle with 3 meals a day. Man, I say before in my videos, success is a very short window. If you want to build something, a house or something, a car, a motorcycle, success, your life, sports, Olympia, win an Olympic medal, whatever the hell you're doing, success is in a very short window. You achieve that success very short. You don't go there 20, 30, 40 years trying to build muscle forever. You either build it or you don't build it at all. You understand me? Yeah.
You to stimulate in a single meal. However, because that limit increases with fasting after exercise and might increase to a higher level for muscle protein breakdown than for muscle protein synthesis, I think it's probably not necessary to have more than 3 meals per day. The current data don't show any advantage of that. If you like this type of evidence-based content,
then you'll be going to the gym forever, exercising for seeking the 3 meals a day. That's such baloney, man. It depends on what you're seeking there, the modality. What are you trying to chase? Just mass? Do you want more nascent muscle fibers and cells and more mass? Like, what exactly are you trying to achieve there? Or do you just want to come in chronically lifting and creating glycogen muscles? Because all my testosterone's low, I need more high testosterone, or I have to lift heavy to get higher testosterone so I can fill up my muscles with more glycogen, a sex hormone. Like, it all depends on what you're doing. I don't know. So what? You want to do a PR? You want to lift heavy? What are you trying to do? Oh, you want to build some muscle because you are lifting heavy, and so you want some muscle on top of that? I don't know. Protein synthesis exceeds this breakdown. Got to eat more protein. Never mind about this 20 gram stuff this guy's shooting, man. He's making this stuff up. He didn't really prove anything. He did show some small cohorts there, some studies, but they weren't sufficient to prove what he was saying. And I can prove more in other reports that I had on my old channel, but I have to go and scavenge for them now because my old channel was taken down. My community section was filled with all these reports. I could go back and look at them for reference purposes. But now I don't have them anymore, so I have to go back and look for everything. So it's complicated. But that was pretty much the gist of it, what I just said. But anyways, that's my part. That's his part. I agree with some things. I don't agree with everything he says, but that's just me, man. I'll see you in the next one. Touch, think about that. Like, subscribe, support the channel. I'll see you in the next one, broski. Ciao, my friends.